Hi students, in the last lecture we have discussed kinematics of simple harmonic motion and we have solved a problem basing on that. Let us now solve some more problems basing on kinematics of Shm. Let us see question number 2. A particle executing simple harmonic motion and its x coordinate is given by x equal to a sin omega t. Find time taken by the particle to travel from x equal to 0 to x equal to a by 2 and also from x equal to a by 2 to x equal to a. So this is a question given. So if you want, you can try the question once of your own. Then you can see the solution. Let us see now how to solve it. So we are given how position coordinate of the particle changing. That is x equal to a sin omega t. And we have to focus time taken to travel from x equal to 0 to x equal to a by 2. When t equal to 0, x equal to 0, right? Because sin omega t becomes 0 when t equal to 0. I am writing here. Right. So when you are taking t equal to 0, just a minute, this is okay, right. Right. So when you are taking t equal to 0, x equal to 0. So now x equal to a by 2. X equal to a by 2 means omega t should be equal to pi by 6. That is what we have taken here, pi by 6. Now in the place of omega, we are writing 2 pi by capital T, where capital T stands for time period. Then we get T equal to T by 12. So it is a very simple one. So time taken from 0 to A by 2 is a T by 12. Right. Now in the same way from A by 2 to A. See, we are knowing that to travel from, I am drawing here, from x equal to 0 to x equal to A. That means from mean position to right extreme. This is what we call 1/4 oscillation. I am repeating, from x equal to 0 to x equal to a. This is 1/4 oscillation, mean position to right extreme. In the same way, right extreme to mean position, 1/4 oscillation. From mean position to left extreme, 1/4 oscillation. And again from left extreme to mean position, that is 1/4 oscillation. So this totally is one oscillation. So now here from x equal to 0 to x equal to a, this is a 1/4 oscillation. And for this time taken is, it is a t by 4. So now what we are doing here is to calculate time taken from a by 2 to a. We are subtracting t by 12 from t by 4. Because t by 12 is a time taken from x equal to 0 to x equal to a by 2. So for remaining a by 2 to a, time taken is now t by 4 minus t by 12. And that is a t by 6. That is what we have written here. And if you observe, to travel from x equal to 0 to x equal to a by 2, time taken is less compared to a by 2 to a. The reason is that while traveling from mean position to right extreme, Speed is keep on decreasing. That's why it covers the first half of the distance in less time than the remaining half of the distance. So we got first half of the time. It is t by 12. First half of the distance, a2, sorry, it is 0 to a by 2. So time taken t by 12. To track to cover remaining distance, it takes t by 6. Means double the time. Because speed is decreasing while moving from mean position to extreme position. That is one point we have to keep in mind. Right. Let us now go for question number 3. A particle executing simple harmonic motion and its x coordinate is given by 4 sine pi t, where x is in centimeter and t is in second. Find the smallest distance, sorry, find the distance traveled in the time interval t equal to 0 to t equal to 7 by 3, t equal to 0 to t equal to 8 by 3. Right. Then see what he's asking here. Yeah. Distance traveled in the time interval from t equal to 0 to t equal to 7 by 3 and 0 to 8 by 3 seconds. Right, coming to the solution, see how we are solving it. So if you want, you can try the question of your own once. After that, you can see the solution. Right? Okay, let us see now how to start this one. Especially when you want to calculate distance travel, we should be very careful. So here particle is following a straight line path, but direction of motion, it is continuously changing. So whenever direction of motion changes, we have to calculate distance traveled very carefully. Let us see here what is given. X equal to 4 sine pi t. Let us make a diagram for this one. X equal to 4 sine t. From the function we can say when time t equal to 0, x equal to 0. Right. So time t 0, x equal to 0. This is a time t equal to 0. And we want to take a time interval 0 to 7 by 3 seconds. First calculate here what is a time period. So in this time period, will be omega is given pi. So time period equal to 2 pi by time period equal to, it is a 2 pi by omega and omega value pi. So it is equal to 2 seconds. That is a time period. And given time is now 7 by 3. That 7 by 3 is written as here you can see 2 plus 1 by 3. So why I have taken like this 2 plus 1 by 3. So 2 seconds means it is a completing one oscillation because time period we got 2 seconds. So it is a completing one oscillation. So when it completes one oscillation, it covers a distance of 4 times of its amplitude. That is a 4 4 16. I am repeating. We got time period as now 2 seconds. And here we are given time 2 plus 1 by 3. That is 7 by 3. So 2 seconds, it completes one oscillation. Extra time is now 1/3 second. So in this 1/3 second, What is now distance covered? That is what we have to focus. I think here solution part given not for this function. Let me do one correction here. The function should be, it is not a sine, it should be cos. Just make a change in the question. It is a 4 cos pi t. So in that case, when time t equal to 0, it will be at extreme position. And here x is 0. So it is now extreme position. So this question you have to focus very carefully. There is a possibility of making mistakes in while calculating distance traveled. At time t0, x equal to 0. And we got time, it is now how much means 2 plus 1 by 3. That is 7 by 3 written as 2 plus 1 by 3. So 2 seconds, it completes one oscillation. So one oscillation means you can see it again comes to the right extreme. Means 4 plus 4 plus 4 plus 4. Total is 16. So I have written here 4 into 4, 16 in first 2 seconds. Now focus in the extra 1/3 second. Extra 1/3 second. See what I am doing here. I am writing the value of x. X equal to, just a minute. X equal to, yeah. So the value of x equal to, I am taking in the extra 1/3 second, right? So it becomes a 4 cos pi by 3, means 4 cos 60. It is a 4 cos pi by 3, an extra 1/3 second. 4 cos 60, it is now 2, right? So it is now given 7 by 3 seconds. So 2 plus 1 by 3. Already it has finished. It has finished one oscillation, remaining 1/3. It covers now 2 centimeters. Sorry, it's actually 2 here gives us position coordinate. And luckily you are given amplitude is now 4. Therefore it is now 4 minus 2. That is I have written here 4 minus 4 cos pi by 3. So 16 plus 2, it is 18. Right? So here one thing is that we are given amplitude is a 4. So luckily, whether you count from right extreme to x equal to 2 or from mean position to x equal to 2, distance covered is the same. But remember, x equal to 2 gives us a position coordinate. It is not distance traveled. Then what I am doing is here, if you observe carefully, in this part, I am writing 4 minus 4 cos pi by 3. Because of 4 cos pi by 3 gives us, that is a position coordinate. So distance traveled from right extreme position to up to that location is a 4 minus 4 cos pi by 3. That is now 18. Okay. And now see carefully here. The next one given time interval 0 to 8 by 3 seconds. It is 0 to 8 by 3 seconds. That 8 by 3 written as 2 plus 2 by 3. So in first 2 seconds, it completes one oscillation. Therefore, Distance traveled is 4 into 4, 16. Now in the remaining 2/3 second, we have to focus distance covered how much. And I am writing here x equal to 4 cos x equal to, so I am writing here x equal to 4 cos in the extra 2/3 second. So it is now becoming 2 cos 2 pi by 3. Just a minute. I will erase this one. Right. So we are calculating in extra 2/3 second distance covered how much? It is a 4 cos 2 pi by 3. Cos 2 pi by 3 means cos 120. Cos 120 minus 1 by 2. Therefore, it is equal to minus 2 centimeter. Now, students focus carefully. After 2 seconds, it comes to right extreme position. Now, in the extra 2/3 second, if you observe, x value will be minus 2. And you see, minus 2 is where? Minus 2 is now here. Get the point. X equal to minus 2. X equal to minus 2 is here. That means it has a traveled distance from where to where? Right extreme to mean position, that is 4. From mean position to x equal to minus 2, extra 2. So totally it is a 4 plus 2. You can see here in first 2 seconds, 4 into 4, 16. Next, we got here x is a minus 2. That means right extreme to mean position 4. I have written here from mean position to minus 2, extra 2. So totally 22 centimeter. That is the answer. So while calculating distance traveled, we should calculate very carefully. Because if you want to calculate displacement, directly put the value of t in that. We get x1 and x2. And x2 minus x1 gives displacement directly. There is no confusion. It is a very simple one. That's why mostly in the examination, they won't ask questions like displacement. They ask questions like calculate distance traveled, because at equal time intervals, direction of speed is changing. Sorry, direction of velocity is changing. Right? So I hope you got that clarity.